BC right now would not be the right thing.
So are they getting you live, or are they?
They're getting a flipped experience. So I'm filming class every day, and then they get the video after class is over. They watch it at night, and then anything these guys would do for homework, they're doing in class.
Wow.
We're trying out some things.
I love it.
All right, Mr. Spielberg, we're good?
Yes.
All right, asymptotes. Asymptotes. When I say asymptotes, what comes to mind? There are vertical asymptotes. Can anybody think of a parent function that you know of that has a vertical asymptote? I'm going to wait for there are a couple of hands here. Aaron.
1 over x squared.
1 over x squared. Love it. The graph of y equals 1 over x squared looks like this guy here. Some folks think of it as like a volcano. Some people think of it as like the witch's hat. Great. There are vertical asymptotes and horizontal asymptotes. Can you give me an example of a parent function with horizontal asymptote?
To the power negative x.
E to the power negative x. Is that increasing left to right or decreasing left to right?
Decreasing.
Decreasing left to right. All right, what you have is you have 3 minutes working with whoever you would like around you to, on this paper here, identify all the parent functions that you can think of that have either a horizontal asymptote or a vertical asymptote. I just want this to be your download of all the parent functions you know of that have asymptotes. If you need to use your parent function survival guide, that's fine. I'm all about hair now that I'm in my 40s.
Yeah, exactly.
Thanks for stopping by, Mr. DeBella. All the parent functions you can think of. Sketching a graph would probably be a very good idea. I can think of like 10. Maybe I'm just showing off.
Yeah. Maybe this one. RKA. Oh, yeah.
I really think it would be a good idea for you to like provide yourself a sketch as well.
Wasn't that the same thing as that, though? Wasn't it the same thing
Yeah,
as that?
that one.
It's all about
The next one's gonna be this one. The positive. Natural log.
Yeah. That's a version.
This one. Or is it which
I feel
one?
like this is more horizontal. But it's not really 1 over x squared minus 1.
No, it's,
But
it's basically gonna be 1 over x squared. So minus.
The minus 1 is just go for this part right here.
Yeah.
All right, friends, let's hold this together. We've already got y equals 1 over x squared and y equals e to the negative x. And if I really want to get specific, we're going to say that 1 over x squared has a horizontal asymptote at y equals 0 and a vertical asymptote at x equals 0. Graph of y equals e to the negative x has a horizontal asymptote at y equals 0. What other parent functions do we know of that have asymptotes? Aaron, give me one, then you're frozen for a little bit.
Okay, for horizontal asymptotes, you have y equals x squared.
Y equals x squared. Wait, that's the parabola, right?
Yes. Oh wait, no. Wait. I meant to say the other one.
Okay, a y equals x squared does not have any asymptotes.
I mean 1 over x is fine.
You meant 1 over x?
Yes.
Ah, okay. Y equals 1 over x. Aaron, what kind of asymptotes do we have there?
You have isn't it 2?
There's 2. Tell me about it.
We have a vertical and horizontal asymptote.
Okay, vertical asymptote. Where does that vertical asymptote live?
Y equals 0.
Ooh, I want to be careful. Vertical asymptotes
Right. X equals
are
0.
always x
Exactly.
equals.
And
So vertical
horizontal-
asymptote at x equals 0, and this guy has a horizontal asymptote at y equals 0. Okay, you're frozen for a little bit. Other ones.
Natural log has a vertical asymptote at x equals 0.
Y equals the natural log of x has a vertical asymptote at x equals 0. How about the horizontal asymptote? Trick question. It has none. Other ones. Other ones. Stephen.
Would it be like multiple? It'd be y equals cosecant.
Oh, good thoughts. Y equals the cosecant of x. Now, cosecant of x, I gotta tell you, is not one that I necessarily have memorized, but when I bother to look it up in my parent function survival guide, I remember that the graph of cosecant of x looks something like this. Because cosecant is the reciprocal of the sine function, whenever the sine has a root, the cosecant graph has a vertical asymptote. So you're going to have a vertical asymptote at x equals 0. Where's the next place that the sine has a root?
Pi.
Sine of pi is equal to 0, so that means you're going to have a vertical asymptote over here at x equals pi. The next one?
Negative.
Okay, yep, if you want to go over this way.
That's you.
Bless me, yes. Vertical asymptote at x equals negative pi. This guy over here has a vertical asymptote at x equals 2 pi. If I asked how many vertical asymptotes does the cosecant graph have, you ought to all tell me.
A lot.
Oh, a lot. Very mathematically specific. Yes, I thought some people might argue it has 4. 4 is a lot on a Friday morning. The actual right answer, how many vertical asymptotes does this graph have?
Infinity.
An infinite number of vertical asymptotes because we have this function that just keeps repeating. Great. Any other parent functions? Tangent of x. Now we're getting there. The graph of y equals the tangent of x looks something like that. Vertical asymptote at pi over 2. Another vertical asymptote at x equals negative pi over 2. Great. There's 2 more that I want to get on your radar screen. Lewis? Yeah, secant. All right, yeah, secant. That's a good one too. There's another one that I really want to get on there.
Y equals the absolute value of x over x.
Absolute value of x over x, I wouldn't technically call those asymptotes, right? That's the graph that kind of does like this thing.
Yeah.
Those aren't asymptotes because you're not getting closer to y equals negative 1 or y equals 1. You're like there. Palemo?
Natural log.
Natural log, good. We've already got that one. Lewis, you got one for me?
1 over x squared minus 1.
Ah, 1 over x squared minus 1. Okay, definitely. The one I want to draw your attention to, though, is going to be y equals 1 over x squared plus 1. Okay, that's the one that has the little hill. And there's one more that you may not necessarily have on your parent function list yet, but oh, it's coming. It's an important one. And Stephen, you might want to turn the camera so that the friends at North Central get this as well. The graph of arctangent of x. Probably not one that immediately comes to mind, and that's okay, but I do want to get this on your radar screen. Graph of arctangent of x is a special one to always think about because this one has 2, count them, 2 horizontal asymptotes. All the other ones that we have over here have 1 horizontal asymptote or no horizontal asymptotes. But the graph of arctangent has a horizontal asymptote over here at y equals pi over 2. And you're going to have another horizontal asymptote over here at y equals negative pi over 2. Don't freak out over this one if you're like, no, I don't remember this from pre-cal. it's okay. Just maybe you want to put a little star next to this because this will show up. Okay. Are you okay?
Yeah.
All right, so let's get technical, shall we? And I want you guys to do, if you flip over to page 28, please, we have what we're going to call the college definition of horizontal and vertical asymptotes. What I want to keep straight in your head, you already know a lot about asymptotes. But what I want to do today is redefine. I want to stretch your knowledge of asymptotes using limits. So, Giselle, if you don't mind, can you read the college definition, the textbook definition of asymptotes?
As x approaches infinity, or as x approaches negative infinity, if the graph of y equals f of x approaches the horizontal line of y equals L, then the line y equals L is called a horizontal asymptote of the graph of f of x.
This is the textbook definition of a horizontal asymptote. So David, if you were to go home tonight and pull out your calculus textbook that you don't have and look up horizontal asymptote, this is what you're going to see. So as x approaches infinity, you guys know what that means, going that way, the graph of y equals f of x, so my function, approaches the horizontal line y equals L. Approaches, doesn't necessarily get there,
No.
approaches, okay? So if I've got my graph, and here's the line y equals L, I'm pretty sure you guys know this from all your other courses. Whenever we deal with asymptotes, we do like the dotted line. It's a guideline. You don't actually ever get there. You're getting closer. According to this definition, as x approaches infinity, the graph of y equals f of x approaches the horizontal line y equals L. So maybe we're thinking something like that. Is that approaching y equals L?
Yes.
Yeah. So my notation, I could say it's the limit as x approaches infinity of f of x equals L. And if I want to get really fancy, I'm approaching L from above. So in terms of the y values here, would I say from the right of L or the left of L? You need to have like a number line orientation here.
Oh, wait, no.
If my graph is above y equals L, those y values are bigger than L. Imagine it on a number line, you're going to be coming in like from the right. It's a little weird because you can see it from above, but we're going to say like from the right. Is there another way to approach y equals L? Okay, we could come in from below. Okay, and here I'm going to say this means the limit as x approaches infinity of f of x equals L, but we're going to say it's coming in from the left. This is an example of a horizontal asymptote at y equals L, and I'm going to say on the right side of the graph. The right side of the graph. I could also be approaching negative infinity, and I'd say then the limit as x approaches negative infinity of f of x equals L, but I'm approaching from below. And my graph could look like this, and then I would say the limit as x approaches negative infinity of f of x equals L, and I'm approaching from the right. And so this is going to be horizontal asymptote at y equals L on the left side of the graph. More of a technical definition than maybe what like you're used to thinking about. Is everybody mostly okay with this? Okay, let's see how good we are with this. Can somebody think of a parent function that has a horizontal asymptote on the right side but not on the left side? Horizontal asymptote on the right, but not on the left. Go back to those parent functions if you need to. Horizontal asymptote on the right, but not on the left. I see Stephen. I see Polymon. Horizontal asymptote on the right, but not on the left. Polymon, give me an example.
Square root of x.
Square root of x actually does not have a horizontal asymptote. That graph increases and continues to increase. It doesn't get closer to a finite number. Stephen?
Y equals e to the power of x.
Y equals e to the power of x. Does that have a horizontal asymptote on the right, but not on the left?
I need to check.
Well, yeah. What does that graph of e to the x look like?
Right there.
Graph of e to the x increase. This is e to the negative x. So this guy, e to the negative x, has a horizontal asymptote on the right, but not on the left. Can anybody think of a parent function that has horizontal asymptotes that look like this? 1 over x. How about like this? Negative 1 over x. How about like this?
1 over x squared.
1 over x squared would do that. How about two different horizontal asymptotes?
Y to the
Which one? Arctan. Now, granted, you got the advantage that they're like right in front of you. Arctangent is an example of a parent function that has two horizontal asymptotes. Two horizontal asymptotes are possible. Can anybody think of a parent function that has these two asymptotes?
Oh, x equals y squared? I think.
What? Let me ask the question one more time. Can anyone think of a parent function that has this kind of behavior? One more time. A parent function, emphasis on function. There is no parent function that could ever have this kind of behavior. There is no function that could ever have this kind of behavior because you would fail the vertical line test, right? That vertical line test, you can't draw a vertical line anywhere and have it cross the graph more than once. That'll never happen. Now, here's the tough one. Could your graph do something like that?
Possibly, yes.
Could your graph cross the horizontal asymptote?
No, there's no.
Our definition of horizontal asymptote says, as the limit as x approaches infinity of the function, we get to L. It is possible to cross a horizontal asymptote. You can cross a horizontal asymptote in between. You can even cross the horizontal asymptote like on the way out, like maybe your function kind of wiggles a little bit and then eventually flattens off. Those things are okay.
Squeeze here.
No, we're not squeezing. We're not going to squeeze each other in calculus class. No. All right, so let's move on. David, can I get you to read the technical definition of vertical asymptote?
As x approaches k from the right,
Yep.
or as x approaches k from the left. If y approaches infinity, or if y approaches negative infinity, then the vertical line x equals k is called a vertical asymptote of the graph of f of x.
Perfect. So let me draw on a vertical line at x equals k. X equals k. Our definition here says as x approaches k from the right, if the y values approach infinity. I'm approaching k from the right, and the y values head off to infinity. So this is limit as x approaches k from the right of f of x equals positive infinity. Does that fit your definition? Does that like fit everyone's understanding of a vertical asymptote? Okay. What if I did that? Still a vertical asymptote?
Yes.
My notation here, though, is going to be limit as x approaches k from the left of f of x is going to be positive infinity. My graph could do that. I'd say that's the limit as x approaches k from the left of f of x is negative infinity. Or my graph could do that. Limit as x approaches k from the right of f of x equals positive infinity. And we've got parent functions that have this behavior. 1 over x squared. Parent functions with this behavior.
Mhm.
1 over x. Parent functions with this behavior. Negative 1 over x squared. Parent functions with this behavior. Yeah, I'm not going to fool you guys twice with that question. It would not be a function. We're good? We're tight like my pants? Okay, good. Oh, I guess Steven's acid wash jeans there. All right, so here's what I want for you to do. I'd like for you to get up and find a new friend to talk to. I realize you guys have been together for a very long time. I'm going to take control of the camera. Everyone's going to gather on that side of the room so that we can have some conversation. Please grab with you page 28 of the handout. And I want you guys to have some conversation about 1 through 5. Okay, we're having like girl time and boy time. And these two are not moving at all.
I'm doing your survey.
You're, okay, let's do
I
some.
finished it.
Thank you so much. Thank you, Aaron.
Okay, let's learn some asymptotes.
Same function as the other one, vertical asymptote.
Actually,
Yeah.
what is it?
Oh, we have.
Wait, 1 over x?
Okay, you guys know the North Central kids are all staring at your butts right now. There you go.
We should have some.
Yeah, so you could have those nice.
Yeah. Yes.
It's like if you go from one, not sure.
Right
what's
after.
the-
Or Giselle, I
Say
need to know. I need to know.
that's that
Well,
they
Well, we don't know. What's
Still
4?
has a whole-
4 is yes.
It's still like not close to it.
Okay.
Still.
Giselle, thank you. You're going to
I think.
You already went.
It's less.
What's up, man?
Say yes.
I said, we said yes.
All right, you guys get about 1 more minute to lock in your thoughts here in these 5 questions.
Would you? Aaron, 4?
No.
Why not?
Wait, vertical asymptote?
Yeah.
Right, I need more than yes or no. Give me an example or a counterexample. Yes because, no because.
Yeah, no, it can't. It can't.
Cosecant of x
Because it has to go. Yeah, it wouldn't be continuous unless because of less. Would it be continuous if it had that vertical asymptote? Well, you can. Can you pass it?
All right, when I say calculus, you say ready. Calculus.
Ready.
Calculus.
Ready.
All right, question number 1. Can a function have more than one vertical asymptote? If so, I need an example.
Yes, cosecant of x.
Cosecant of x works. Other ones? Secant. Other one. Tangent of x. Other one. Cotangent. Can a function have more than one horizontal asymptote?
Yes.
Yes. Which one?
Arctan.
Arctan. It was like angels just answering the question. Everyone knew arctan. Mr. Link is so proud. All right, number 3. Can a function which is continuous have a horizontal asymptote?
Yes.
Can a function, okay, if we have a continuous function with a horizontal asymptote, Aile, can you think of an example?
Y equals e to the power of x.
E to the power of x. Excellent. Other ones. Continuous parent functions that have horizontal asymptotes. We get e to the x. 1 over x. Would that work?
Wait, for horizontal. I thought I could.
The question is, can a function which is continuous have a horizontal asymptote? And I hear you offering 1 over x. I don't like 1 over x.
Yeah,
1 over x
that's
squared.
what
1 over
I'm
x.
saying.
I like that even less. Go back and read the question one more time.
That's not continuous.
Andrew, what's the problem? The graph of 1 over x is not continuous. The graph of 1 over x squared is not continuous. I'm looking for continuous examples. Continuous examples like e to the x, like e to the negative x, like 1 over x squared plus 1. These are all good examples. Polymon, you okay? All right, number 4. Can a function which is continuous have a vertical asymptote? Vertical asymptote. The answer here, heck no. Heck no. No vertical, if your function is continuous, think about any function that you would draw that's continuous. You cannot have a vertical asymptote with if the function is continuous from negative infinity to infinity. All right, can a function ever intersect its horizontal asymptote?
Yes.
Yes. Okay. Probably something though that if I had asked you guys earlier, you would have said no. Because all the parent functions that you know, they like approach their horizontal asymptote, but they never cross. It's possible to cross. Everybody okay? Excellent. Let's keep pushing. We've only got 16 minutes left. If we're lucky, we're going to do one problem from start to finish. All right, Stephen, if you could fix me up here, make sure I'm looking good.
Makeup or?
No, I look good all the time. Part of my contract. All right. So here's the thing. Stephen, are we good over here? All right, so here's the thing. On Monday, you guys are going to have some time to explore with your calculator. And what I want to do today is we're going to go limits, all in on limits. All in on limits. Take a look at this function, 5x minus 10 over x squared minus 4. You guys would have worked with this a little bit in Algebra 2 and a little bit in pre-calculus. And I bet some of you might remember there are some tricks for finding asymptotes. Do you remember any tricks for finding asymptotes? Stephen does. There are some tricks. Okay, Andrew does.
Factor.
Andrew, what do you remember?
So we factor the denominator,
You factor the denominator.
and then those the zeros for the denominator, or when you factor it,
Yep.
and then the zeros for the numbers is going to be the asymptote.
So what I hear you saying is you would focus on the denominator. You'd figure out where the denominator is equal to 0. You'd like solve that equation, and then that tells you where the vertical asymptotes are. Is that all familiar? Does everybody agree with him? Because he's totally wrong. Partially wrong. Partially wrong. Hold on.
I think if I remember, we would focus on the two biggest, like the top one 5x and the bottom one is x squared.
Yeah.
You just focus on those two. If since the bottom one's gonna be bigger, that's what you're gonna base it off of.
Okay, so you're looking at the fancy word here is it's the degree. Degree 1 in the numerator, degree 2 in the denominator, and you would have some conversation with self that sounds something like, hey self, where's the degree bigger in the denominator? So what happens? What's the horizontal asymptote?
Are you asking? Like for
Yeah, I think that was a question.
for that?
Yes.
Uh-huh.
For that.
And so here's the thing, like, even though the 11 of you are like wicked smart, and so are the other 5 or 6 on the other end of this camera here, students coming out of Algebra 2 and pre-calculus don't really have a complete understanding of asymptotes. So here's what we're going to do. We're going to go back to our definition of a horizontal asymptote. Go back to the last page. What's the technical definition for horizontal asymptote? How do we find them? How do we properly find them?
X.
Oh, awkward panda. How do we find a horizontal asymptote?
Oh,
Our technical calculus definition. Aaron, what's that technical definition?
can you read the horizontal? As x approaches infinity or as x approaches negative infinity, if the graph of y equals f of x approaches the horizontal line y equals L, then the line y equals L is called the horizontal asymptote of the graph of f of x.
Well said. Thank you for that. What I heard you say first is it's about what happens as x approaches infinity. This is what I want to figure out. I want to figure out what happens as x approaches infinity. We're going to go back to our definition. Well, as x approaches infinity, now, bummer, you can't actually plug in infinity, right? That doesn't make any sense to us. Well, what happens as x approaches infinity, though? What happens in the numerator?
It increases.
The numerator increases like towards infinity.
Yes.
How about the bottom?
Same.
Samesies. Infinity over infinity, what's that equal to?
That's not possible.
Is that 1?
Of
A
course.
number divided by itself is 1.
Yeah, but
It's
it's
Infinity.
But these are infinities. Infinity is not a number.
The concept.
What this is a new indeterminate form. This is indeterminate form number 2. Now, I don't think it's like technically named that in a book anywhere. It's not like number 2, but it's an indeterminate form. Just like the other indeterminate form that you guys know. 0 over 0. So I've got a new trick for you. Okay? We're going to try some algebra fun here. Going to blow your mind. 5x minus 10 over x squared minus 4. I am going to look at this and I'm going to say, what's the biggest degree that I see in the entire problem? I see x squared. And what I'm going to choose to do is I'm going to multiply by 1 over x squared over 1 over x squared. First question, is that legal?
Yes.
Okay. Legal to multiply by 1 over x squared over 1 over x squared because?
Fancy one.
Fancy 1. This is just fancy 1. I can even make my fancy 1 for y'all. There you go, fancy 1. There it is. Now, second question, the really important question is that better? Does this make the problem better? And you guys right now would be like, I really don't know. Let's try it. Let's see what happens. Limit as x approaches infinity. I'm going to take this 1 over x squared and multiply it to both terms here. So I'm going to get 5x over x squared minus 10 over x squared. In the denominator, x squared minus 4 gets multiplied by 1 over x squared. So what I get is x squared over x squared minus 4 over x squared. Some of you might be thinking, that doesn't look better at all. It is. Check it out. Limit as x approaches infinity. 5x over x squared is the same as saying 5 over x minus 10 over x squared. X squared over x squared, 1, minus 4 over x squared. If I take the limit as x approaches infinity of 5 over x, x gets big. X heads off to infinity. 5 over x. X is getting really big. What do you think? I want to know about the limit as x approaches infinity. If x is approaching infinity, 5 getting divided by some number that's approaching infinity.
It's gonna be getting close to 0.
Getting closer to, everybody okay with 0? 5 candy bars divided by my infinite number of friends, we get chocolate dust. Okay, and yes, I have no friends, I know. Okay, limit as x approaches infinity of 10 divided by x squared.
Same thing.
Samesies, right? Big number, gets squared, it's huge now. 10 divided by huge, 0. Down here, 1 minus 4 divided by x squared, 0. What's that final limit? 0. What that means is that I have a horizontal asymptote at y equals 0. And because I've only approached it from positive infinity, I would make this clear and be like, this is on the right side of the graph. Technically, what you should do is run through the same analysis with the limit as x approaches negative infinity. And this is going to get you your like left side horizontal asymptote. And I'll tell you in this one, they're going to be the same. Yep. Welcome to calculus class. This is how we find horizontal asymptotes. Now, somebody, Polymon, were you the one that was remembering the thing about the degrees?
Yeah.
Okay. Here's the thing about the degrees. Degree 1 in the numerator, degree 2 in the denominator. Which one's bigger? 2. That means that the denominator grows faster. So 5x minus 10 is growing. It is approaching infinity. X squared minus 4, though, because the degree is bigger, it grows faster. If the denominator grows faster, 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 faster than the numerator does, everything collapses to 0. You're going to get a horizontal asymptote of y equals 0. There are other cases you might be thinking, like, wait a second, what if it's 5x squared minus 10 over x squared minus 4? What if it's a tie? Something else happens. We'll talk more about that on Monday. But in the world of calculus, when I ask you guys to find horizontal asymptotes, I want you to check on the right side of the graph, so that's limit as x approaches infinity. And I want you to check on the left side of the graph, that's going to be taking the limit as x approaches negative infinity, just to make sure you got them both. Because could we have two different ones? You could have two different horizontal asymptotes. Everybody okay? All right, I'm boring Lewis. That can't be a good thing. All right, I'm going to eliminate all this stuff because now we get to go for a little bit more fun, which is looking at vertical asymptotes. With vertical asymptotes, it's going to take a little bit more thinking on the front end, but I think you guys are like going to be fine with this. Was it Andrew that you said you wanted to focus on the denominator? What is it that you did with the denominator? Okay, well first of all, we're going to set the denominator equal to 0. And we're going to solve this. Now, some of you are going to like maybe move the 4 to the other side, say x squared is equal to 4. And so the solution is going to be plus or minus 2. The factoring people are not going to run into that problem. They're like, oh, x plus 2 times x minus 2 is equal to 0. X plus 2 is equal to 0. Or x minus 2 is equal to 0. So we get negative 2 and we get positive 2. Now here's the thing. These are not necessarily vertical asymptotes. What these are your candidates. These are not your political candidates. Let's not have that conversation. Okay, your candidates for vertical asymptotes are going to occur where the denominator is equal to 0. For us to have a vertical asymptote, we need to come back to our definition of limits. If x equals 2 is a vertical asymptote, then when I take the limit as x approaches 2 of that function, something has to happen. Something very specific has to happen. What has to be true if we have a vertical asymptote at 2? You might want to check your notes. What must be true if you have a vertical asymptote at x equals 2? Lewis, what has to be true? In terms of the limit, what has to be true? It's a limit definition I want you to think about. So go back to that definition. What has to be true if you have a vertical asymptote?
X equals the actual asymptote.
Not quite. Something has to be true about the value of this limit. You know that you're going to have a vertical asymptote because the limit has to be either positive infinity or negative infinity. Right? A vertical asymptote, you're expecting the graph to shoot up really high or go down like towards negative infinity, unbounded behavior. So what I need to do is we need to evaluate this limit and figure out what's happening. So let's do it. If I start off, like my first thing is probably going to be maybe like direct substitution. What happens there?
You didn't know it was 0.
You're going to get 0 over 0 indeterminate form. We know, do some algebra. Easy algebra here.
still divide by 0, which should be
We can factor. 5x minus 10 is the same as 5 times x minus 2. X squared minus 4 is x minus 2 times x plus 2.
5 over
X minus 2's cancel, and what do we get?
5 over
5 over 4. Does that meet the criteria to be a vertical asymptote?
Wait.
Look at your
It
definition.
has to be infinity.
In order to say that you have a vertical asymptote at x equals 2, what you need to have happen is you need to get infinity or negative infinity. Is that what's happening? No. And if we had a little bit more time, we would have graphed this function on the calculator, and you'd see that the function 5x minus 10 over x squared minus 4, it has a problem at x equals 2, but it doesn't have a vertical asymptote. What it has, because this is not one of the infinities, right? So this is not positive infinity or negative infinity. What you have is you have a hole at x equals 2. Right? I cannot evaluate my function at 2. That would put 0 in the denominator, and that's a bad thing. The location of your hole is at x equals 2, and the y coordinate for the hole is 5 over 4. There is a vertical asymptote. What we're going to do is we're going to take the limit as x approaches negative 2 of 5x minus 10 over x squared minus 4. And if I try evaluating, as x gets closer to negative 2, what happens in the numerator?
Negative 20 over 0.
You're going to get negative 20, and in the denominator?
0.
0. Now here's where you need to be careful. It looks like I'm plugging in negative 2, but we're having limit conversation. With limits, the question is what happens as you get close. So the numerator gets close to negative 20. The denominator gets close to 0. The numerator gets close to negative 20. The denominator is getting close to 0. The whole fraction is getting close to
0.
not 0. It's either getting close to positive or negative infinity, really depending on what side of negative 2 you're approaching from. And so here my conclusion would be vertical asymptote at x equals negative 2. Love it. Ended right on time. Everybody out! I'm not writing notes.
I don't know where I go.
If you have a class in the gym, you must be an athlete, so you can run.
That's not true. There's 6th graders who are class in the gym.
You can knock them to the... Wait.
Never picked up a ball in their life.